Okay, so question 4, does there exist a second order linear homogeneous differential equation such that all its solutions are even functions? Wow. So what kind of even functions do you know? So I don't know. Let's try to just reason logically. So even functions. So what do we know about even functions? So let's just think of a few even functions. So like y equals t square is an even function. So y equals cosine t is an even function. So y equals, what else do you know? Maybe t to the 4 is an even function. Well, but what is kind of the main property of even functions that may help us? So here you need to be kind of a little bit creative, and then maybe if you plot a few even functions, you will realize that all even functions, they share a very important common property, so that specifically the derivative of an even function evaluated at 0 is 0. Well, is it true? Well, let us try to prove this fact. So is it true that every even function satisfies this property, that its derivative evaluated at 0 is 0? So suppose that y of t is an even function. Right? So if y of t is an even function, it means that y of minus t equals y of t. But then let us differentiate this equation. So taking the derivative, the left-hand side, according to the product rule, the derivative is going to be minus y prime of minus t equal y prime of t. And now, letting t be equal to 0, we see that minus y prime of 0 equals y prime of 0. So moving y prime of 0 to the right-hand side, we get 0 equals to y prime of 0. So y prime of 0 is 0. So yes, all even functions satisfy this property that y prime of 0 equals 0. But then we can easily answer the original question. It means that the answer is no, because if we consider the initial condition y of 0 is 1 and y prime of 0 is 1, then such an initial value problem has no solution. So the solution of such an initial value problem cannot be an even function. So solution of this initial value problem cannot be an even function, because every even function satisfies the condition y prime of 0 is 0. And since we have an initial value problem that does not have a solution, this contradicts the Picard-Lendelov theorem of existence and uniqueness, and therefore the answer is no.